Hi, I'm Steve. This is my Tesla 2022 Model S Long Range. It's my dream car. I waited a year for the thing, and it's everything I hoped it would be, except for one thing: the suspension. I was aware of Tesla's reputation for a stiff, fairly uncomfortable ride, not really compatible with the horrible street conditions here in my Michigan hometown. But I wasn't worried because their sales literature describes that this car has air springs with adjustable shocks, a very sophisticated suspension system that, when set into comfort mode, will allow me to drive down the road in silken smoothness, I think the sales literature on their webpage says. The problem is I can't detect any difference between their sport mode and their comfort mode. It doesn't seem to be adjustable at all, and it never has. I took it into service, of course, and they checked it out very thoroughly. They checked the mechanics of the linkages as well as the whole air spring adjustable shock setup. And actually, they did replace a part. It turns out that the electronic control unit, the ECU for the air spring system, was inert. So they fixed that. So now I know that I have a perfectly functioning system. The problem is, even with a functioning ECU, there still isn't any comfort mode. Problem is, they say that everything is working perfectly. So the question is this problem real, or am I crazy? Is this just the way it's supposed to work? I went on the Tesla Motors Club forum and talked to a number of other Tesla users, and sure enough found 12, 15 other people that have the same problem I have. The problem is that driver testimony is extremely unreliable when you're trying to diagnose whether this system is functioning. What's needed is an objective test of the system's functionality. This is what I proposed to do, and this is why I made this video. In the video, I'll show you what test I did, why I did what I did, and its results. And as a spoiler alert, I don't have adaptive ride control. The comfort mode is a mere illusion as far as this car at least is concerned. And since I believe that it is a firmware error, I think a great number of other people out there may have the same problem. So I'm going to show you what I did, and we'll take a ride, and I'll show you how the system actually in action. And I made this video in hopes that since Tesla service has already helped out all they can, and they've been really great about replacing all the parts that need replacing and making sure that it's functional, but the thing is out of their hands now, I think. The problem has to be fixed by someone at Tesla who is responsible for the programming of the system. So I hope that this video will be seen eventually by somebody who can do something about it, who will take action. Now, before I start showing you what I did, I think a thumbnail description of how this type of a system works would help you understand why I'm doing what I'm doing. This car has air springs, which simply they're little airbags that replace the coil springs and provide the actual weight-bearing capacity for the vehicle. In this car, those work fine. There's no problem at all with that. The problem comes in with the other part of the system, the adjustable shock absorbers. A shock absorber generally is nothing more than a cylinder full of oil with a piston in it. One end of the piston is connected to the wheels and the cylinder is connected to the body, and for that piston to move, the oil must move back and forth from one side of the piston to the other. the oil can't move, the thing is a solid bar. If the oil can move freely as the piston tries to move in the cylinder, then the shock will be considered to be soft. So you can adjust it from firm to soft by changing the passageway, the little orifice that allows oil to flow from one side of the piston to the other. In this car, that's done electrically through solenoid valves. These are proportional valves, and you can envision them as a conical plug sitting in a hole. Now, the plug, if you lift it just a little bit, you will expose only a small passageway for oil to go through. If you lift it a lot, it'll fully open the hole, so it's proportional. The higher you lift this little tapered plug, the easier the oil can flow and the softer the shock becomes. These solenoids are controlled by DC voltages. I proposed to measure those voltages under actual driving conditions. Other than try and connect underneath the fender where it's difficult to get to the wires, I removed the front trunk tub and all the trim here to expose this bundle of cables that goes to the shock strut. There are four wires in there, 2 for each of the solenoids on the shock absorber. I got a tapping device to tap 2 of them reliably, and I honestly don't know which solenoid I'm connected to, the compression or the rebound, but it really shouldn't matter, as these things have to be kept pretty much in balance with one another. If you open one more than the other for any length of time, you end up with shock pumping, as they call it, where the shock absorber will sort of pump up or pump down to the easiest direction it can go in and hit the stops and stay there. So either one of the solenoids should be representative of what they're both doing. I ran a long cord, carefully routed, and connected it to my oscilloscope. This is better than a voltmeter, as the oscilloscope is actually a dynamic voltmeter. It gives you a trace of voltage versus time, and so we will be able to see exactly what kind of a signal they're putting on those solenoids. Okay, we're in the car now, and I've got the shock absorbers activated. All you have to do actually to activate the shock absorber solenoids is step on the brake. You do not have to be driving. You don't actually have to be moving at all. I've started out by putting it in sport mode, and you can see on the oscilloscope that what we have here, despite my unstable scope, I haven't used this in years, so it tends to be flipping in and out. But what we're seeing there is a pulsed DC voltage. What they often do with these damper solenoids is they pulse them. This one is pulsed at 1,000 cycles per second, 1 kilohertz, and it's about a 16-volt signal. They do this, I believe, just to keep the solenoids from sticking. It tends to make them vibrate a little bit, and they think that it keeps it from sticking shut. In any event, instead of putting a variable voltage on the solenoids to close them or open them, what they are doing is changing the duty cycle of the voltage. The duty cycle is since this signal turns on and off, the bottom line represents off and the top peak represents 16 volts. The thing flips on and off and stays on for a certain period of time and off for the rest of the time. What you're seeing now is perhaps a 20% duty cycle. it's on 20% of the times, off 80% of the time. They vary the power to the solenoid by increasing or decreasing that duty cycle. There we go. So the voltage stays the same, the duty cycle changes. Now this is in sport mode. Now when I go to advanced and the damper setting is now in firm, notice that it got a lot smaller. Now I will go to next to the firm, it got smaller yet, and we're getting to softer. Now we're mid-soft and it's tiny. This to me is actually backwards from what it should be. We should be getting a higher and higher duty cycle, not lower and lower. Here is second to the lowest, it's the same as middle, and here is the softest, and it's the same. So essentially, the softest setting that we've got on this system is sport mode, looking like that. Everything else we do, I'll go to comfort. It disappears entirely. Comfort has pretty much a 0 duty cycle. Really odd. But if you go to advanced and then you can set this, this is supposed to be the softest, this is the next firmest, this is the second to the firmest. You get a little bit of duty cycle there, and the firmest is maybe 8% duty cycle, and sport being the widest, you're doing the most. If you ask me, when you go into advanced, what you should have is firm should be about 20% and soft should be 100%. That thing should be up at the top all the time. So that is why we don't really have a comfort mode. This thing is set, however this is set. They have not programmed in the base values to give the kind of ride you're calling for in the user interface. Now, one thing that I've found in actually driving the car is that it looks just like this, except that it takes as a base value the duty cycle that it's showing. As you hit a lot of bumps, the suspension adapts and it actually adds a little bit of width to the pulse, so it gets a little bit softer. But in each of your settings, sport, comfort, or any of the ride comfort, firm to soft settings, it starts as the base value of what the first duty cycle in there is, and then it gets a little bit wider as you hit a lot of bumps. I won't try to actually drive around with this filming setup because everything would be bouncing around and you wouldn't really see that happening anyway. But that is the way it works. I have done it while driving. As long as we're here, let's talk a minute about this display. Is anyone else as confused as I am by it? There are two areas that bother me. One is the diagram, the car with the green and red lines, and the other is the compression and rebound damping percentages shown. I don't have any problem looking at the diagram. It looks like a perfectly familiar description of a suspension in operation. The green line shows the path the wheels take over the pavement, and the red line shows the path the body takes. The problem comes when you read the labeling for these lines. The red line is labeled compression and the green line labeled rebound. That actually just isn't true. If that were the case, then one would be a mirror image of the other, as compression is just negative rebound. I think what they really meant to label them was unsprung for the green line and sprung for the red, or more prosaically, wheel, path of wheel and path of body, or better yet, just leave the description off. Everybody knows what this diagram means anyway. The compression damping figures are interesting too, in that they are just wrong. As I have shown with the oscilloscope measurements, when you are in comfort mode, there is essentially maximum damping, but this thing shows 0%. When you go into sport mode, I registered maybe about 20% duty cycle on the shock absorber solenoids, which would give you like, I don't know what, maybe 80% compression, 80% damping, but this thing shows 20%, 28%. It's almost like it's backwards. I can't figure it out at all. An interesting note is that the percentages here that you see pretty nearly match up to the duty cycles that I was seeing on my oscilloscope. I just don't know what's going on with that. So there it is. With the results of this test, I don't think that anybody could argue that the system, as it's implemented in this car at least, is operating the way the Tesla engineers intended it. Many of the values that we were reading appear to me to be simply random or garbage. For what it's worth, it's my opinion that a system like this will maintain a firmware table. This table will have a space in it for each of the different ride modes: sport, comfort, the 5 levels of softness, and advanced. And in each one of those spots, the table will be initialized to contain the duty cycle appropriate for that ride mode. When a user interface calls for one of those ride modes, the system will go to the table, displace in the proper number of spaces, and pull out the value that's there and enter it into the electronic control unit. I think that process has become corrupted somehow. The table is full of garbage, or it was never set up, or it's being addressed incorrectly, or there's a word length difficulty. Anyway, it isn't working as intended, and it is my hope that at some point a Tesla engineer will see this video, will look into it, and fix it. Until then, I know my car and the cars of probably many other Tesla owners will be missing one of the major advertised features.